Dr. M.A. Bhagaveni, Professor, Department of Electronics and Communication Engineering, College of Engineering Gindi, Anna University, Chennai. Dr. M.A. Bhagaveni graduated from Government College of Technology, Coimbatore, has completed her Masters and PhD at College of Engineering Gindi, Anna University. Her field of interest includes cognitive radio, ad hoc networks, wireless sensor networks, and wireless communication. She has completed 2 projects, one for CVRDE and the other for DST. She is the recipient of Young Scientist Award from DST. She has got 2 Best Research Paper awards in international conferences. She has published more than 70 research papers in reputable journals and conferences. She is author of 2 books. The one is Analog and Digital Communication and the other is Cognitive Radio, an Enabler of Internet of Things.
Welcome to UGC lecture series for the BSc Honours. This session we are going to cover the experiment, amplitude modulated signal, transmitter and the receiver. The aim of the experiment is to transmit voice signals using amplitude modulated transmitter and to receive it using an amplitude modulated receiver. To do this experiment, you will be in need of the following apparatus, where the amplitude modulation transmitter kit, the amplitude modulator receiver kit, connecting probes, the cathode ray oscilloscopes or digital storage oscilloscopes, microphones and a speaker. The theory of AM modulation: we have AM transmitter. So, the normal amplitude modulated transmitter signals are very popular. We hear voice, music signals using the radio which is available in our house. This received signals at our house is transmitted at specific broadcast stations called radio station. So, there they allocate certain frequency bands to transmit the radio signals, like each band is about 10 kilohertz. This frequency band will be centered around one center carrier frequency for each station. A station at 610 kilohertz on the dial of the transmitter is, it means it is at a carrier frequency of 610 kilohertz. The signal will be broadcasted between the frequency range of 605 kilohertz to 615 kilohertz. So, every radio station will occupy a channel bandwidth of 10 kilohertz. This 10 kilohertz will be centered at various frequencies like 610, 625, etc. So, 610 will be a station, maybe a Vivid Bharati station. So, every center carrier frequency will be popularly called by its local names. So, that is how we can receive the signal and we can enjoy the music that are played over the radio stations. So, in general, with this we can understand that the amplitude modulated transmitter should be capable of transmitting the local voice signal. Voice will be occupying between 0 to 3 kilohertz. This voice signal or any music signal which may occupy few band of frequencies ranging from 0 to hundreds of kilohertz. These frequencies are to be mapped on to a center frequency, and from that center frequency and the total message should be contained within a bandwidth of 10 kilohertz. The transmitter signals are nothing but the audio signals, which includes the speech, or music or advertisement. So, the input to the AM modulator is to modulate the input signals to a proper carrier frequency. So, in AM modulation experiment, we have seen how a given signal is being modulated to another frequency called as carrier frequency. So, the modulated signal will be then amplified and then transmitted using an antenna. So, this process is called AM transmission. So, you take up the source signal, The source signal will be amplitude modulated by the amplitude modulator, and then you need to amplify the signal. This amplified signals are transmitted using an antenna. This is the basic block diagram for the amplitude modulated signal transmitter. The AM modulator transmitter consists of the following blocks: the signal block, which will be a voice signal or a music signal or any other signal. This signal will be passed into a amplitude modulator. The AM modulator will imbibe this message signal amplitudes over the amplitude of the carrier signal Fc. So, we have considered a simple example of 610 kilohertz being the center carrier frequency. So, you will be having a carrier of 610 kilohertz. Over that carrier signal, the amplitude of the carrier signal will be varied with respect to the voice signal which has been given as the input. So, at the output of the modulator, we will be having AM modulated waveform. This AM modulated signal will be mostly in millivolts to volts range, this which cannot be transmitted to a longer distances. In order to achieve faster or wider coverage, we have to convert this minimum signal to a high power signal. That is done by the power amplifier. The power amplifier converts the amplitude modulated signal values to kilowatts of power, and then this power is broadcasted using antenna. This is what is there in AM broadcast stations: amplitude modulator, power amplifier, and this power amplifier will feed on the signals to an antenna. The antenna will broadcast the signals. So, signal, we know it may be voice or the music or any other information that we need to transmit. They are going to be modulated using an amplitude modulator. So, few details about the modulator. The modulator converts the frequency of the input signal from the audio range to the carrier frequency of the station. For audio range will be 0 to 5 kilohertz, which will be converted to 605 kilohertz to 615 kilohertz. This process will be carried on and done by an amplitude modulator. So, here is an example of where the frequency range will be for the message signal, will be between 0 to 5 kilohertz. After modulation, the frequency shifts to 605 kilohertz to 615 kilohertz, and the center frequency being 610 kilohertz. So, this is how the modulator maps the all the input signals to the required frequency center frequencies. So, after this modulation, a simple sync input signal, this is not a voice signal. In order to see how the amplitude modulated signal will be, I have taken up this small example. So, you can have a single tone signal like this. When you get an output modulated signal, the modulated signal will have the message signal over it envelope. You can see this envelope will have the message signal. The amplitude of the carrier is changed with respect to the amplitude of the message. So, you can see the message signal over the amplitude of this carrier signal. So, this is the output of the modulator. After modulation, we have to power amplify the signals, and after power amplifications, they will be provided to the antenna to broadcast. The purpose of the antenna will be, it converts the current or the voltage signal to an electromagnetic signal, which will be radiated in this space. So, this is the use of an antenna. If you want to transmit the signal using wires, you need to deploy wires from the transmitter to the receiver, where the wires can conduct electrical signals. But if you want to radiate the signal or broadcast the signal, you need to use antennas, which will convert the electrical signals to electromagnetic signals, and they can be radiated in this space So, it occupies the electromagnetic frequencies and the signals are transmitted in this space or broadcasted in this space. So, this broadcasted signals are received by a radio at our home. So, we will see how the receiver now it is going to collect these signals and repeat it or play it at our home premises. So, such devices are called as AM receivers, amplitude modulated receivers. The amplitude modulated receiver will receive the signal from the desired amplitude modulated transmitter station as well as the signals from other amplitude modulated stations. So, over the broadcast the transmitter is not going to transmit only one station signal, it will transmit many station signals. So, all these signals are available in air. So, they will be picked up by the AM receiver. So, it can pick up all the audio signals like FM station signals, TV station signals, cellular phone signals and any other source of electromagnetic radiations. All these signals will be available at the antenna of the receiver. From this set of signals, my AM receiver will just pick up the AM modulated transmitted signals. So, it cannot demodulate or reconstruct the FM modulated signals or television signals or cell phone signals etc. Since all these signals are broadcasted in air, so everything will be available as electromagnetic energy at all the places. So, a receiver will receive all these types of signals. The particular AM receiver has to receive only the intended frequency and then reconstruct it and play the voice or music. So, the signal at the receive antenna will be sum of all of these frequencies. So, these electromagnetic signals that are received at the antenna are not just one station signal, it is all the signals. So, the AM receiver main purpose is to separate the desired signal from all other received signal and using its frequency characteristics. So, the receiver first purpose it has to pick up only the signal of interest. For that we popularly use a receiver called as super heterodyne receiver. We popularly use a receiver called as super heterodyne receiver. Super heterodyning is a type of a receiver where each station, whether if they are centered at one particular frequency and are going to occupy a bandwidth of 10 kilohertz. So, you will be receiving frequencies of 610 being the center frequency, then 625 being the center frequency, like that. So, all these stations will be received. So, to pick up a bandwidth of 605 to 615, you need to design a filter and then reconstruct it. To pick up next station, you need to design a filter from 620 to 630 kilohertz and then reconstruct the signal and hear it. So, for each and every frequencies, we are going to design a separate receiver, then it will be of the transistor may not be of handy size, it will be occupying a big room. So, to avoid that, there is a principle called as super heterodyning. This according to this principle, the frequencies will be converted or translated to a frequency called as intermediate frequency. The frequencies, all the different frequencies which are occupying 10 kilohertz, a band of 10 kilohertz centered at various carrier frequencies for each station. Once they have received, they can be translated to intermediate frequency. This process is called as heterodyning. You will be using a mixer or a multiplier. This takes up two inputs, one will be from the received signal, the other will be from a local oscillator. So, message signal plus the signal from the local oscillator. After the mixer, you will get mixer or a multiplier, you will get sum and different frequencies f c plus f m, f c minus f m. So, like this different frequency will be concentrated, that is translated to a frequency called as f c minus f m. After the mixer, we will be passing it to a low pass filter. This low pass filter will transmit only a lower frequency and the higher frequency will be filtered away. So, this lower frequency is called as intermediate frequency or IF, intermediate frequency of IF. Now, we can recover this, we can use the demodulator to demodulate this intermediate frequency. So, whatever might be the transmitted signal, after the mixer we will end up with a frequency called as intermediate frequency. After the intermediate frequency, just one chain of circuit is enough to reconstruct the amplitude, demodulate the signal, and we can hear the signal. So, that is the principle of super heterodyny. So, inside this we will be having a mixer, low pass filter, which will convert to IF. After IF, we will be reconstructing the signal, or we will be using an envelope detector to detect the amplitude changes of the received signal, amplitude demodulator, and demodulate the signal, power amplify it and use it to feed a speaker. So, this will be the internal circuit of an AM receiver. So, the popular AM receiver will be called as super heterodyne receiver. This is the type used in most modern radio receivers. The desired signal is first translated to an intermediate frequency and then recovered by a demodulator. The receiver block diagram, the received signals from the antenna are amplified because it will be of very less power, and they are amplified, passed into an IF mixer. This IF mixer will just add up the received signal and one local oscillator signal, provides sum and different frequencies, and that different frequency is called as intermediate frequency. This intermediate frequency is IF amplified using an IF amplifier. After the amplification, we pass the signal to an envelope detector, which is nothing but the AM demodulator. This AM demodulator will produce the message signal being the output, removing away the carrier. This message signal will be audio amplified, it will be in the range of audio frequency. So, it is audio amplified, and this signal will be provided to the speaker where we can hear the voice. So, this is the block diagram of the AM receiver, popularly called as super heterodyne receiver. In addition to these blocks, we have tuning blocks to tune the gain at various stages and have a common gain, for we can just pick up the required station and amplify the signals. So, the details of the each blocks is the antenna captures the electromagnetic energy. Its output is a small voltage or current. In the frequency domain, the antenna will be just picking up the RF signals, it will pick up all range of frequencies. The desired frequency will be of one center carrier frequency with its bandwidth. So, this is the desired frequency range. Only this signal should be separated out from all the undesired signals. You will be having both FM signal, AM signal, TV signal, mobile signals, etc. From all these signals, we will have to receive one particular station and hear the details from that station. So, first the antenna will receive the set of signals. After it receives, it will be amplified. The RF amplifier, RF stands for the radio frequency. The RF amplifier amplifies the small signals from the antenna to voltage level appropriate for transistor circuits. The RF amplifier also performs a band pass filter operation on the signal. It just filters or attenuates other frequencies and picks up the desired frequency. After the desired frequency range of 10 kilohertz has been filtered and picked up, from 610 you need to filter it from 605 to 650. So, that process is called as filtering, and you will be doing it using a band pass filter. The band pass filter attenuates all other frequency components and picks up only the required band of frequencies. So, after RF amplification, all undesired signals will be removed, only the desired signal will be passed on to the RF amplifier. The RF amplifier amplifies this signal to a voltage level that is suitable for the transistors to operate for the super heterodyning purpose of converting the center carrier frequency to IF level. So, that part is called as an IF mixer. IF is intermediate frequency. The IF mixer shifts its input in the frequency domain from the carrier frequency to an intermediate frequency value of 455 kilohertz. Whatever might be the input signal, finally, after the IF mixer, the frequency of the signal will be 455 kilohertz. So, from 610, after the mixer, we get a signal centered at 455 kilohertz and occupying a bandwidth of 10 kilohertz, right. After IF shifting, we go for IF amplification. The IF amplifier band pass filters the output of the IF mixer, eliminating essentially all the undesired signal. Now, finally, we have only the desired signal which is centered at 455 kilohertz. This signal will be demodulated using an AM demodulator, which is nothing but a simple envelope detector. The envelope detector converts the amplitude of the received signal and and it will give you a message signal only. The message present on the amplitudes of the carrier will be picked up by the envelope detector, and therefore, finally, at the output of the envelope detector we will be having the transmitted audio signal. This audio signal will be amplified using audio amplifiers. So, the signal will be of very poor, very meager in amplitude values. So, they need to be amplified for they can drive a speaker. So, the audio amplifier amplifies the signal from the envelope detector, it provides power to drive the speaker. So, that is the entire theory behind the transmitter and an AM receiver. The procedure to view these signals are, we need to switch on the transmitter, trainer, check the power supply to be about 9 volts, connect the microphone to the point marked mic in the trainer kit. To transmit audio signals, we have to talk through the mic. The audio signals are amplitude modulated, power amplified and transmitted by the antenna. This transmitted signal we can view at test points named as aerial using a digital storage oscilloscope. Since the audio signal is of range of signals occupying 0 to 5 kilohertz, the signal that is viewed at the aerial output will not be exactly looking like an AM modulated signal, envelope of an AM modulated signal. You can just see it will be like somewhat like a noisy signal, because every carrier frequency is AM modulated within the band of frequencies. Okay. So, we can view those signals at the point named aerial, because at that point the signal is converted to the RF range and transmitted using an antenna. So, we can view that signal using a digital storage oscilloscope. To receive this signal, we need to just turn on the AM receiver trainer kit, check the power supply to be 12 volts, connect the speaker to the point marked on the trainer kit. So, with the help of the tuner, now the tuners are nothing but they are the frequency adjuster of the band pass filters. So, once you tune properly, you are varying the required center carrier frequencies of various stations. As you tune the knob, you just try to pick up various stations. Okay. So, with the help of tuner, we need to tune it in order to get the exact channel over which our voice is being transmitted. So, we tune it in such a way that we can hear our voice through the speaker. So, when we are able to exactly pick up the transmitted frequency at the receiver, we can hear the voice over the speaker. So, with the help of tuner, tune the circuit to the required frequency, which is broadcasted by the AM transmitter kit. Now, we can observe the voltage and waveforms provided at the various test points. So, generally the receivers are characterized with certain parameters like selectivity and sensitivity. Selectivity, how selectively a receiver is capable of picking up a particular station, that is called as selectivity. So, in definition, it is a measure of the receiver's ability to separate the received signals. So, we have already seen in the air, in the electromagnetic form, we are having all types of signals, including mobile phone signals, FM signals, AM signals, etc. In AM itself, there are various stations. So, from all these things, the capability of the receiver is it should exactly pick up the required station. So, it should have the ability to pick up the required station and therefore, remove or neglect other signals. This process is called as selectivity. The another important parameter for the receiver is sensitivity. Sensitivity of the system is measured is the capability of the receiver to reconstruct weak signals. It is usually measured in decibels. The signals are transmitted over the air. There are many other AM modulated signals. There is a possibility that over the same frequency band we will be having other transmitters also. So, the present signal may go as weak as possible. Even under weak condition, the receiver sensitivity will be determining how effectively my signals are reconstructed at the receiver. So, this usually measured in terms of signal to noise ratio in decibels. The SNR of the receiver will say that how effectively it can reconstruct a weak signal. These are the two measures which we will be performing while doing the experiment. One is selectivity, other is sensitivity. Selectivity is usually quality factor of the tank circuit, how effectively it can tune or resonate to a particular center frequency. So, that is called as a Q factor or selectivity factor for the picking up on particular range of frequencies. Sensitivity will be usually measured in terms of signal to noise ratio. What will be the signal power to the noise power my radio station is capable of reconstructing. So, finally, the results, the audio signals is transmitted using the AM transmitter. The receiver is tuned to receive the transmitted signals and they are received at the AM receiver. To prove that, we have amplitude modulated the signal and received at the receiver. So, finally, we will be able to transmit our voice and receive it using the AM receiver which will be played by the speaker. In summary, to do this experiment we need to turn on the transmitter kit and transmit our voice signals through mic. These signals are amplitude modulated, power amplified and transmitted through the aerial. The receiver kit is turned on, the speakers are connected, the tuner is tuned to receive the received transmitted signals. Then we can hear a speech through the speaker at the receiver end. So, this is the overall summary of the experiment. Few questions, we just find out where amplitude modulation is popularly used for audio signal transmission. We would have studied many modulations like AM modulation, FM modulation, phase modulation. Out of all these modulations, AM is most popularly used for audio signal transmission. Why other modulation techniques are not employed? You can just identify what is so important about, what is so beautiful about AM modulation. It is that reason that all audio signals are always AM modulated. Second question, what will happen if the sensitivity of the receiver is very poor? If the sensitivity of the receiver is very poor, what will happen? We have already told sensitivity is nothing but the capability of the receiver to pick up weak signals. If the sensitivity is very poor, means it can pick up signals that are of better SNR. It cannot pick up weak signals, means your receiver is incapable of receiving many stations with poor signals. If the sensitivity is very good, it can receive many AM signals or radio signals, even it is very poor in signal strength. Third question, what will happen if the selectivity of the receiver is very poor? If the selectivity of the receiver is very poor, selectivity is the capacity of the receiver to pick up the desired station. If the selectivity is very poor, what will happen? We will be having crosstalks. It will pick up the nearby stations in addition with that of the signal that is transmitted in this particular station, and finally, we will end up with crosstalks. We cannot hear even a single station properly. So, selectivity and sensitivity are most important parameters which are used to study the receiver's capacity. And also you can find out few applications where AM modulation is used in today's setup. So, with this we finish this session. Thank you.